Amanda invests $500 monthly in a high-risk investment because it potentially has a high reward. The investment loses money during the first 6 months. Amanda tracks the total amount invested and the total amount lost over the first 6 months of her investment in a table. What is Amanda's investment worth? Should Amanda continue to pay into this high-risk investment? Justify your response. Okay, so we have our columns here with principal invested, which is the f of x, so how much money she's putting in, and then the investment loss for just the first 6 months. And so we want to know over time, will this continue? And to know something over time, generally, we're going to need to come up with generalized equations for these. And once we do that, then we could just take the amount that she invests and subtract that investment loss. And we can see, will that ever end up actually being greater? Will this trend ever reverse in her losing so much money? And so let's go ahead and start by finding finite differences. And so first note that our delta x here is changing by a rate of 1. And then let's also find the finite differences for f of x by starting at the bottom and subtracting the next number for each one. And so note that these are each 500 apart when we subtract these, and so this will be a linear function. And so we know it'll be f of x equals mx plus b. And to find m, we just need to take the delta y divided by delta x. And we know that our delta y here is 500, the constant change, and then divided by 1, our delta x. So that will be 500. And then b is our y-intercept. So when x equals 0, then note that f of x equals 0. And so our function then, we can fill those in. Instead of m, we can put 500x, and then since b is 0, we don't need to put anything there. And now let's go ahead and find the finite differences, doing the same thing for g of x. So we see here that these are not constant, and so it's not going to be linear, so you can go ahead and subtract the next pair, again starting from the bottom, going up, just subtracting each pair. And again, in the next set, then we notice that these are not the same, and so we can just keep going and subtract the next pairs. And in the last try here, then we do get a constant rate of negative 18 for our third difference, and so this will be a cubic function. So let's go ahead and pull up our cubic function rules. And so using these, let's start here. So we know that 6a will equal the third difference, which in our case is negative 18. So dividing by 6 to solve for a, then we get a equals negative 18 divided by 6, which is negative 3. And then to get b, we know that 6a plus 2b equals the second difference between x equals 0 and x equals 1. So that will be 30. And then for 6a, that will be negative 18 plus 2b equals 30. And so we can add 18 on each side to solve. And so we get 2b equals 30 plus 18, which is 48. And dividing by 2 to get b alone, we get b equals 24. And then to get c, then we know, I'll just work up here, a plus b plus c equals the first difference between x equals 0 and x equals 1, which in our case will be 81. And so plugging in the others, we know a is negative 3, b is 24, and then plus c equals 81. So negative 3 plus 24 is 21, plus c is 81. So subtracting 21 on each side, then we get c equals 60. And then lastly, d is just g of 0, so our y-intercept. And so when x equals 0, g of x is 0, and so we know that d will equal 0. And so using those things, we can go ahead and write this equation. So we know that g of x will equal negative 3 for a, x cubed, and then for b, 24x squared, plus 60x for c, and then d is just 0, so we don't need to put that. So now that we have both these equations, then we can take f of x and subtract g of x and see what is the equation then for the amount that she'll have after the money that she's lost from the investment. So I'm just going to go ahead and copy these on another page so that we have more space. Okay, so now that we have these, then we want to know these subtracted give us a positive amount, and will this turn around? So let's go ahead and subtract these. So 500x minus, and then make sure to have parentheses around this whole other part, and then distributing the negative into all of the different terms, then we get 500x minus negative 3x cubed will give us plus 3x cubed, and then minus a positive will give us minus 24x squared, and then minus a positive 60x will give us minus 60x. And so then we can combine any like terms. So 500x minus 60x gives us 440x. So let's go ahead and put this in order. So we'll have 3x cubed first, minus 24x squared plus 440x. And so from the looks of things, this is a positive cubic, and so this should actually go up by a very great rate. Being a positive cubic, we know that those go up at a fast rate, and so it looks like this will be worth it. Let's go ahead and graph it compared with what she would normally make without the investment, which is the 500x. So I've gone ahead and I put our f of x equation into y1 and our f of x minus g of x into y2, and then graphing those, then we see that the straight line is the 500x, the f of x equation, and then the other line is what it would be subtracting the investment lost. And so basically we see that at about right here they intersect, which is about around x equals 10, then it actually surpasses what she's putting into the bank account. And so we do see that this investment will end up being beneficial if she just sticks in it over 10 months. Okay, so now that we have that information, we can go ahead and summarize our answer. Using the patterns and the finite differences in the table, the amount of principal Amanda has invested can be represented as f of x equals 500x. The amount of loss Amanda's investment has experienced has constant third differences, and so it can be represented by the cubic function g of x equals negative 3x cubed plus 24x squared plus 60x. The worth of Amanda's investment is f minus g of x equals 3x cubed minus 24x squared plus 440x. The long-term prospect for her high-risk investment is good, since it is described by an increasing cubic function. If the table is continued, the investment loss eventually decreases and the investment starts to make a profit after more than 10 months. Amanda should continue to invest if she plans to invest long-term.